Welcome everyone. Today we're going to dive into one of the most essential libraries in the Python ecosystem for anyone interested in data. That library is called Pandas. If you've ever worked with data, spreadsheets like Excel or more complex databases, organizing, cleaning, analyzing, Pandas makes this process easier and more powerful within Python scripts. High-performance, easy-to-use data structures and analysis tools used by data scientists, analysts, and engineers. So, why is Pandas so popular? It simplifies how we interact with structured data, brings spreadsheet functionality into Python with more flexibility and power, handle large data sets that might crash Excel. In this tutorial we'll cover the absolute basics to get you started. What a data frame is, how to load data from a CSV file, and simple functions to inspect and understand your data. By the end you'll have a solid foundation and confidence to use Pandas. I'll break concepts down step by step, so don't worry if you're new, we'll go through code examples and explain each line. Let's get started and see what Pandas is all about. So what exactly is a data frame? This is the most important concept to grasp when you start working with Pandas. In the simplest terms, a data frame is a two-dimensional, size-mutable, potentially heterogeneous tabular data structure with labeled axes. If that sounds too technical, don't worry. Picture a spreadsheet. Picture a single table in a database. It has rows that represent individual records. It has columns that represent different attributes or variables. Each column in a data frame is what Pandas calls a series. Think of a series as a single column from that spreadsheet. A data frame is a collection of series that all share the same index. The index are the row labels. For example, an employee dataset might have columns for first name, last name, email, salary. Each column is a series. Together they form the employee data frame. This structure is intuitive to work with. A data frame can hold different types of data: numbers, integers or floats, text, dates, Boolean values. This flexibility is crucial for real-world data. For instance, salary numeric, first name and email text. Pandas handles all of this behind the scenes. Everything you do in Pandas revolves around creating, manipulating and analyzing data frames, filtering rows that meet criteria, calculating summary statistics for a column, merging multiple datasets together. Data frames are the fundamental building block for data analysis in Pandas. The most common way to get data into a data frame is by reading it from a file. Pandas supports many file formats including Excel, JSON, SQL databases, but the most common one you'll encounter is the CSV, which stands for comma-separated values. A CSV file is a simple text file where values are separated by commas. To read a CSV file, we first need to import the Pandas library. The standard convention is to import it with the alias PD. With Pandas imported, we can now use its powerful read_CSV function. This function takes the path to your CSV file as an argument. Let's imagine we have a CSV file named sales_data.csv. We could load it into a data frame called df with a single line of code. After loading our data, the very first thing we'll want to do is inspect it to make sure it loaded correctly and to get a general sense of what it looks like. Loading a large file with thousands of rows and trying to print the entire data frame would be overwhelming and not very useful. Instead, Pandas provides a handy method called head. This method, when called on a data frame, will show you the first 5 rows by default. You can also pass an integer to specify how many rows you'd like to see. For example, df.head10 would show you the first 10 rows of the data frame. This is an essential first step in any data analysis workflow. It's a quick sanity check that confirms your data is structured as you expect. It lets you see the column headers and a few sample records, giving you immediate context for the dataset you're working with. Once you've loaded your data and taken a quick peek with head, the next step is to understand its characteristics. You'll want to know more about the values within each column. For numerical columns, you might be interested in things like count, mean, standard deviation, minimum, maximum. Manually calculating all of these would be tedious. But Pandas provides another incredibly useful method called describe. This method generates descriptive statistics that summarize central tendency, dispersion, and distribution shape for numerical columns. When you call describe on your data frame, it returns a new data frame with a wealth of info at a glance. For each numeric column you'll see count, mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, maximum. This single command gives you a powerful high-level summary, helping you spot outliers and understand scale without complex code. Sometimes you might not need all of describe's output. You may only want one specific statistic, like the average of a column. To do that, select the column and call an aggregate function on it. For example, Select the price column with square brackets and call me. This is clean, readable, and efficient. You can do other stats too: sum, median, max. This ability to drill down and compute specific metrics is fundamental to data analysis. Pandas gives both broad overviews with describe and specific calculations like mean, so you can explore data how you want. This is just the beginning. Explore more Pandas functions. Example code: average_price =df price, mean.